Good day, everyone. Welcome to the newest episode of New Learning. I am Mr. Philip J. Diao. You can call me Teacher Phil, and I will be your physics teacher for today. Our lesson for today is all about absorption spectrum. But before I proceed to our discussion proper, let us read first our learning objectives. At the end of the lesson, you should be able to A. Define absorption spectrum. B. Cultivate curiosity and a desire to explore the underlying principles of absorption spectra. And C. Develop laboratory skills necessary for performing absorption spectroscopy experiments. We know that light is electromagnetic radiation composed of several frequencies of radiation. An ordinary light features a wide range of wavelength with respective frequencies. Electromagnetic waves can travel in a vacuum at the speed of light. The electromagnetic spectrum consists of a span of all electromagnetic radiation, which further contains many subranges which are commonly preferred or referred to as portions. Microwaves, infrared light, ultraviolet light, X-rays, and gamma rays are types of radiation included in the electromagnetic spectrum. When the white light is passed through a medium, they get split according to their respective frequencies and wavelength. The white light spectrum starts from 7.5 times 1014 Hz for the violet color to 4 times 1014 Hz for the red color. The interaction of electromagnetic radiation with matter causes the molecules and atoms present in the matter to absorb energy and reach a higher energy state. This higher energy state is unstable, and hence they have to emit energy in the form of radiations to return to their original states. This process generates emission spectra and absorption spectra. Spectra and spectroscopy. The plural form of spectrum is a spectra. Spectrum is widely used in the field of optics and many more fields. Spectrum features a wide range of wavelength of different frequency radiations. Now, a rainbow is a spectrum that constitutes different wavelengths of light. The spectrum of light from the rainbow is commonly referred to as Roy G. Biv. Now, the prism is also an ideal example to describe the spectrum of radiation. When the white light passes through the prism, it gets separated into different wavelengths of light known as the spectrum. The instrument used to separate the radiations of different wavelengths is known as spectroscope or spectrograph. A spectrometer is a scientific device that aids to separate and measures spectral components of a physical phenomenon. It is a branch of science that deals with the study of the spectrum, are known as spectroscopy. A spectrograph features a prism or diffraction grating that is used to disperse light. The emerging light after the dispersion from the prism is examined using a photographic film. Now, spectra is classified into two types. We have the emission spectra and the absorption spectra. But for today's discussion, we are just going to focus about the absorption spectra. Absorption spectra is constituted by the frequencies of light transmitted with dark bands when the electrons absorb energy in the ground state to reach higher energy states. The type of spectrum is produced when atoms absorb energy. So let's know how absorption spectra are formed. When light from any source is passed through the solution or vapor, a pattern comprising dark lines is obtained. This pattern is analyzed using the spectroscope, depending on the nature of the chemical or element. Certain radiation is absorbed by the chemical or element when passed through it. The dark line pattern is seen exactly in the same place where colored lines are seen in the emission spectrum. The spectrum thus obtained is known as the absorption spectrum, while the emission spectra can emit all the colors in an electromagnetic spectrum. While the emission spectra can emit all the colors in the electromagnetic spectrum, while the absorption spectrum can have a few colors missing due to the redirection of absorbed photons. The wavelength of light absorbed helped figure out the numbers of substances in the sample. The patterns of absorption lines, emission lines, and the continuous spectrum is shown below. And that's all for our topic for today. So do you have any questions regarding to our topic? And since none, let's call it a day. Goodbye, class.